80% of organizations right now are running software with known exploitable vulnerabilities in production. That's nearly 9 out of 10, if my math is right. But that's not the actual problem. When DevSecOps team try to fix this, they hit a wall. If they move slow, to be cautious, the outdated libraries pile up with CVs. And if they try to move fast to be proactive, they risk adopting compromised dependencies within 24 hours of release. So it's not about speed anymore. It's about clarity in a sea of alerts where only 18% of critical vulnerabilities actually remain critical once you apply runtime context. So how do security and engineering teams navigate this without burning out their teams? That's what we are unpacking in this episode of Secure by Design with Andrew Krug, Head of Security Advocacy at Datadog. Andrew, it's great to have you on the show.
Thanks for having me.
And if you ask about this year's report, you folks have been doing this report for, I think this is the third report. What surprised you most in this year's finding compared to previous Datadog State of DevSecOps reports? And what do you think is driving that shift?
Like you mentioned, we do this report every year for about the last 3 years. It's largely focused on kind of the application security and velocity side. When I started my career, I remember we measured success on stability. Like we literally would have leaderboards of how long servers had been up. So like uptime was the measure of success. And since moving to velocity as a measure of success, we've seen teams accumulate vulnerabilities also as a result of velocity. So like that's the big talking point here, is that we sort of have this push and pull between stability, slow movement, and velocity. And I think that's represented in some of the facts in this year's report. So like the big one is most organizations already have some vulnerable dependency in their environment. They just really don't know it yet. And that's reflected in the report facts kind of around vulnerabilities by ecosystem. And I think that's one of the facts that continues to surprise me as we add more language runtimes and more data to that year over year, that we're really not seeing a ton of change in the trends from year 1 to year 3.
Your data shows 87% of organizations running exploitable vulnerabilities. What are the most common barriers that are preventing teams from actually remediating them?
Yeah, I think teams in general are just kind of drowning in findings today. So number one is the triage problem. Number 2 is inside of that prioritized triage, because a lot of products on the market right now are doing like an AI assisted triage, is giving that secondary tier the context that it needs to help your teams prioritize what's next. So something that's public in production and has a reachable exploit is going to be a higher priority than others. So it's really finding the needle in the haystack for these vulnerability remediation teams that's slowing them down. It's not that most teams don't have a desire to patch the vulnerabilities. They're just dealing with this massive list on a daily basis.
There are services using end-of-life language versions facing exploitable vulnerabilities in 50% of cases, compared to 31% for supported versions. Why are organizations still running end-of-life versions when the risk is this obvious and clear?
So I don't have the data to back this up in the report. I only have my opinion as a former practitioner in some of these ecosystems, which is that, if we look at the pace of innovation and the rate of change in the ecosystems, like even just not to pick on Python or anything, but the number of breaking changes in the language itself prevents folks from moving from one major version of a runtime to another without a significant lift. And I think that we see that present also in the Ruby ecosystem, because if you look at Ruby, the number one ORM framework for forever and ever was Rails, and the pace of innovation in Rails really picked up as they approached Rails 6, 4, 5, 6, breaking change. So it was this significant effort to migrate from one major version to the other. And then the long-term support versions of those runtimes just kind of lagged behind. So what I think that we see is kind of a technical debt crisis in the way that folks are building on top of these things that are really core foundation for what their business is doing. And that is more pronounced than ever now that it's super easy to add features to basically anything with agentic coding models.
Now, let's talk about AI. Is AI making things better or worse?
I think in terms of how it's making the problem better is you can have a very strong set of rules, for example, for Cursor or Claude Code or whatever your agentic coding model is to build observability into the application, like as you are putting it together. So for example, I might build a hobby app over the weekend and where it would have taken me a couple of hours to instrument it properly with a platform like Datadog top to bottom, I can just provide a prompt that does exactly the same thing, and I can get all that visibility baked into the app as it's built and released the very first time. Now, not to say agentic coding models don't make mistakes, right? Because given how based on how you're running them, you might be running them in like the unsafe mode or without guardrails, or maybe you just allow all. And I think when that happens, we really lose track of what's going on in the software supply chain as far as like what that model is adding to the project. So it could be, maybe wrongfully choosing to add a library that's like a typo squat or something along those lines that's then going to detonate on your developer laptop, and then you're going to have a whole series of problems after that.
The report also highlights that only 18% of vulnerabilities labeled critical remain critical once runtime context is applied to them. How should security teams rethink their prioritization approach when almost everything gets labeled as critical? Because if everything is critical, nothing is critical.
That's a great question. So I like to say if you label everything critical, nothing is actually critical, which is what a lot of vulnerability management products do. It's very easy to just take CVEs and map them to the criticality rating, based on something like CVSS score. This is where I think Datadog's approach is actually quite unique in that we use 100% of the runtime context that we can to dynamically adjust that severity. So like I mentioned, code reachability is a big part of that. So like, is there actually a potential path to exploitation? Is this attached to a load balancer, or does it have a public IP that's accessible from the outside? And we have a ton of context from just sitting in the position that Datadog does in the environment to be able to calculate that and calculate it in a way that's accurate using data from things like the application's runtime, from the cloud control plane. So that's how we're helping adjust criticality. And that's what's represented in the metric when in the report where we say, if you adjust for runtime context, the number of criticals goes down this much. So when we talk about going back to the initial point on the triage problem, the data really supports that by saying if you have this runtime context data, you're able to triage so much more effectively than you would without that data.
Another thing is that 50% of organizations adopt new library versions within 24 hours of release. It's good to be proactive. But what is the actual risk here? And how do you balance staying current without introducing malicious dependencies?
I think we could speculate on this in kind of a fun way for a minute and ask ourselves, why are these organizations adopting those new library versions so quickly? Is it because they have a high degree of maturity and they're just able to get a release out in 24 hours? Or do we have a case where 50% of organizations are simply pinning to latest and they're actually not doing things like hash pinning in the way that they build their app? Curious what you think. Is it latest, or is it just a high degree of maturity?
Now, these reports, they play much bigger role than just understanding where the market is. How are these findings shaping modern approaches to detecting, prioritizing, and remediating security risks? What's actually changing in practice because of these reports?
Yeah, I will say we run a comprehensive report program that spans multiple domains each year. So this isn't the only report that we do. We actually do 2 security reports a year. One is, kind of application development focused. The other one is Datadog State of Cloud Security. And I think these 2 reports are very effective at kind of shining a light on problems that might not be super prominent or top of mind in the community. And they do really help drive awareness around what you should be driving down in order to have a highly mature security posture. So if we take something like IMDS in AWS, the source of the major data breaches via SSRF from credential theft, years ago, the number of instances running the known vulnerable version of IMDS was quite high. I think it was upwards of 86% the first time that we ran that report. Over the next 2 years, that number trended down. And I think we're at just about 50% now for the old version. So I think the reports are very effective at kind of calling out where practitioners need to focus their time, even if they do have a mature observability product.
Based on the trends you're seeing, what concrete steps should security and engineering leaders prioritize in the next 12 months to meaningfully reduce risk without overwhelming their teams?
So there's quite a lot of guidance in the report, and I would encourage anyone to go check out the full report. We did actually focus a fairly significant portion of it on GitHub Actions this year, and I think that there's been a ton of attention focused on GitHub Actions, especially with the recent set of supply chain compromises from threat actor groups like Team PCP, kind of getting a highly privileged position in very prominent projects. So there is one piece of guidance in here that I think is a no-brainer that everybody should be doing, which is pinning dependencies and GitHub Actions to the full-length hash of those, rather than simply taking the off-the-shelf latest version to run in CI. Because if you think about what it is we're doing in CI today, when we shifted everything left, we put this massive responsibility on platforms like GitHub Actions, where you might not have as much control or observability because that is a third-party hosted runner. So it's up to you to really put the right guardrails on it to ensure that that's building in a way that's deterministic and reliable and secure.
If I ask you, this is 2026, are you happy with the state of security, or you also see cases where you're like, these are solved problems, why are organizations still doing that, where you get frustrated that they can do better and they're not doing it? Where are we now?
Yeah, I would say there are always things that surprise me in breach notifications each year as I kind of page down the major breaches and root causes. So I would say, well, sometimes I am surprised. I am optimistic for the future of security teams because, as mentioned, you said, in EMEA there's great legislation that's encouraging just good security hygiene behaviors. We also see that a lot in APAC as well. There's like lots of amazing data governance legislation evolving in APAC as well. But like really, the thing that makes me optimistic for the future is how AI agents are accelerating security workflows, and they're able to identify, triage, and remediate things in a way that would take entire teams, like maybe months, to action on. So generally optimistic for the future as we move into a space where we can think about security as describing our intent for a complex system. So intent-based security makes me very happy and highly optimistic for the future.
Andrew, after listening to you and after reading this report, what stands out here is that the challenge isn't about patching faster. It is about giving teams the context to act on what actually matters while filtering out the noise, what doesn't matter. Thank you for sharing all those insights. And as usual, I look forward to chat with you again. Thank you.
Yeah, thanks so much.